Hello students, this is Dr. Asif, working as Associate Professor and Head in the Department of Mathematics in Vijaya Vittala Institute of Technology, which comes in Hennur Bagalur Road, Bangalore. Let us discuss today's topic, partial differentiation. In this question, u is equal to e to the power ax plus by into f of ax minus by. Here it is clearly visible that u depends on ax plus by and ax minus by. So you can call it as r and this as s. Then each r and s depends on two variables x and y. So we can infer that u depends on r and s and each r and s depends on x and y. Therefore, we need to prove b into dou u by dou x plus a into dou u by dou y is equal to 2ab into u. Let us start with dou u by dou x. The given function is this, which is a composite function. The given function u is a composite function which can be rewritten as this by taking ax plus by as r and ax minus by as s, where r is equal to ax plus by and s is equal to ax minus by. So here u depends on r and s and each r and s depends on x and y. So therefore, to find dou u by dou x, we need to use the concept of total derivative here. We need dou u by dou x and dou u by dou y. Dou u by dou x can be written as, first let us write dou u here, dou x here, dou u, dou x, here again dou u and dou x. Since we have in between two variables, we have written such a structure two times. If we have three variables here, we will repeat one more time. Now in between here, we write dou r, the first variable which has been taken here, dou r and dou r, and the other variable is s. We write dou s and dou s here. Let us substitute the value of u here and the value of r here and differentiate partially. U is e to the power r into f of s and r, the value of r is ax plus b. Similarly, let us write down these two derivatives now. Dou u by dou s, and the s value of s we will write here. If you look carefully, since we are differentiating this partially with respect to r, we are differentiating. The variable s has to be taken as constant. Therefore, f of s will be constant kept outside. We can see here f of s has been taken as constant. We apply dou by dou r on e to the power r now. Yes, we have applied dou by dou r of e to the power r. Let us differentiate this partially with respect to x. A is a constant, we keep as it is. Differentiation of x with respect to x is 1. Since we are differentiating partially with respect to x, by is a constant, so differentiation goes to 0. We will write plus 0 here. And the derivative of this, here we are differentiating partially with respect to s. Therefore, e to the power r will remain as constant, which has to be taken outside the derivative. Differentiation of f of s with respect to s we have written here. Let us differentiate this partially with respect to x now. A is a constant as it is. Differentiation of x with respect to x goes to 1, and derivative of by, which is a constant, will take 0 minus 0 we write here. Let us rewrite these by differentiating this and this. Differentiation of e to the power r is again e to the power r, we have written, and derivative of f of s with respect to s can be written as f dash of s. This has been simplified as a, and here also it has become a here. Now it is very clear that a into e to the power r is common in both the terms. A into e to the power r we can take outside as common. Yes, we have taken as common. What remains inside? F of s plus f dash of s. So this is our dou u by dou x. Now similarly, let us find dou u by dou y. Dou by dou r of u into dou by dou y of r, thus dou by dou s of u is this, and into dou by dou y of s. S is this value. Now let us find the derivatives. Since we are differentiating this first quantity with respect to r partially, f of s has to be taken as constant, which we have taken. Dou by dou r of e to the power r we have written. And when we differentiate this with respect to y, the value of ax, which will be taken as constant, goes to 0, which we have written here. plus b is a constant as it is. Differentiation of y with respect to y is 1. This completes the derivative of this. Now here partial differentiation with respect to s. Therefore e to the power r has to be taken as constant. We have taken as constant. Dou by dou s of f of s we write now. The differentiation of ax minus by with respect to y partially gives 0 because ax is constant minus b into differentiation of y with respect to y is 1. Let us further simplify by differentiating this quantity and this quantity. Differentiation of e to the power r is e to the power r and differentiation of f of s is f dash of s. Multiply this minus with this plus, then observe b into e to the power r is common in both the terms. B into e to the power r is common. Yes, we can observe b into e to the power r is common now. We have taken b into e to the power r common. What remains inside is f of s minus f dash of s. So as per our requirement, we found dou u by dou y as well. Now consider the LHS of the given equation b into dou u by dou x plus a into dou u by dou y. Let us substitute the values of dou u by dou x and dou u by dou y here. B as it is and a as it is. Let us substitute the values now here and here. This is our dou u by dou x and this is dou u by dou y. Let us multiply each inside. Thus a into e to the power r multiplied by f of s, then plus a into e to the power will be multiplied by f dash of s. The same thing happens here. We'll multiply b into e to the power r inside. Yes, we have multiplied here. Now let us multiply one b also inside the brackets. Here a we will multiply inside. Yes, we have multiplied b inside for these two terms. After multiplying a inside for these two terms, we will get this. That is clearly seen plus ab e to the power r f dash of s will get cancelled with minus ab e to the power r f dash of s. So what remains is 2 times ab e to the power r f of s. This is what remaining in the RHS.